Welcome everybody. Welcome to my talk about a practical guide to a cross-platform Java GUI test. Good to see that there's still people that late in the talks. Before I get started, just a few quick words about myself. I'm Reginald. I'm co-founder and CEO of Froglogic. Previous to that, I worked as a software engineer on commercial stuff like the Qt toolkit, but also on open source projects like the KDE project. Froglogic, we are headquartered in Hamburg in northern Germany. We are in the market now for a bit over 10 years and founded the company with the vision to create a cross-platform, cross-UI technology GUI test automation tool, which is the Squish GUI tester, which is our primary thing we do. In addition to that, we also have a currently only for C, C++ and C# code coverage tool, but we also expand that to Java in the near future. And we are proud to have more than 3,000 customers worldwide using our tools, as I said, mostly for automating all kinds of user interfaces. That's just about my background, about my talk today here. So what I want to do is talk a bit about the different types of testing to define what is actually GUI testing and not mix that with other types which should be done in addition. Why to automate GUI tests, I guess that's something we can cover really quick since the advantages are quite obvious. And then I will try to spend most of the time here on a practical demonstration showing from scratch how to automate a real-world test case on a real-world application. I intentionally did not choose a very simplistic application, as it is usually done in such demonstrations where you show some address book or calculator, but to use a real full-fledged RCP application as application or test. So what different types of testing are there? There are, of course, many, many different types. I guess the most basic or most common type of testing from the development point of view is unit testing, where you test your classes, your code, with the knowledge of the source code, of course, on the API level. Then there are other types of testing like performance testing, stress testing, load testing, and then there's this area of functional GUI testing, which is what we're talking about here today. So functional GUI testing is so-called black or gray box testing, which means that you test the application without the knowledge or without caring how it is implemented. You look at the application from a user's perspective, what functionalities does it offer, how can you interact with it, and how should it behave. So that's a clear differentiation from unit testing, where you test the application with the knowledge of the source code. We really test on a functional level, purely based on the user interface. Since with those kind of tests you can drive end-to-end scenarios, it also suits very well to combine that with other tools, mostly monitoring of loads of performance, code coverage analysis, memory debugging, and so on, since you can very easily drive the full path through your applications with functional GUI testing. Now, doing those functional GUI tests manually is, of course, very tedious, since it takes a long while to run through these tests manually. If you need to do it on different platforms, it even multiplies the time you need to do your tests. So it's very obvious that there are big advantages by automating those types of functional UI tests. This way you can obviously run more tests in a much shorter time. You can easily run the same tests on different platforms, in different environments, different configurations without additional time or resources needed, really. And it's also more reliable and reproducible to run automated GUI tests compared to a human being running them. Humans tend to be lazy, so if you run the same tests over and over again, you start to make mistakes, start to take different routes throughout your test. You might optimize things away, so it might not be always the same thing you're testing, so the results are not for sure reliable. Of course, automated test also has to be implemented properly to allow for reliable results, but that's a different topic. And finally, it allows you to do more interesting tasks. Manual testing application is boring. It's much more interesting to actually automate those kind of things, so it changes the role of the functional GUI tester, but also makes it more interesting to do that. But there's a big but, which is that automating GUI tests is everything but trivial. So a lot of people think I buy an automated testing tool or use an open source tool and that's it, and record some tests and done with it. But the reality is quite far from that. So it's very important from the start to follow a set of best practices, to know of the challenges and the difficulties of automating GUI tests to properly overcome those pitfalls which a lot of people fall into very early, and which is why automated GUI testing often has a kind of bad reputation of being too difficult and too maintenance intensive. So that's covering the basics. Now to the concrete subject of this talk. What I want to do is to automate GUI test on a Java RCP application, and now the steps from deciding that I want to automate a test to getting there is what I sketched out on this slide, which means before I even think about automation or anything or what kind of tool to use, the most important thing is to know what do we actually want to test. We meet a lot of customers who want to automate GUI tests but actually have no idea what are the test cases I want to automate. They have no structure, nothing, and just starting right into automation then doesn't really make sense. The first step is really to define test cases, what kind of functionality are those test cases testing, what is the expected outcome, and only if I have that, it can be in any kind of format, I can start to take specific tests and start automating them. So to automate them, in here I will obviously use our Squish GUI tester to demonstrate that, but it doesn't really matter which tool you use in the end. You will use some way. In our case, it usually starts by recording, so you will start to record your test scenarios to generate the script code for the automation of the application. And that's where the second big mistake often happens, which is to leave tests at that point and just start running those tests in an automated fashion. Recorded tests, I will show that later, tend to not be ideal when it comes to long-term maintenance and long-term lifetime, and therefore it's important to understand what has been created, what does the script code do, and how can I refactor that into smaller functions, and then basically rebuild the whole test case by calling those functions which are created out of the refactoring. For that, you can use different approaches, like a scripted implementation, which I will demonstrate here, or you use a keyword-driven approach, or there are tools like fitness, which you can put on top, which are just different approaches to this kind of abstraction. And then in our case, I wanted to run the test in a cross-platform fashion, since an RCP application can run any platform. You want to test out that the test really runs across the different platforms where you need to test on. And once that's done, the next step is to put all of that into some kind of automation, which means to integrate it into your continuous integrations, which you might already do, make that part of your build automation, test automation, to make sure that those tests from day one are also automated in a way that they are run every night or every build to make sure that you find problems early on and don't pile up a huge amount of tests which you never look at, and later when you put that into a test management system, nothing works anymore. So putting that into an automation framework early on is also very important. So now we start with step number 1 for the practical demonstration, which is to define the manual test case, which are the steps I want to automate. As application or test, I will use an application I could download, which is an Eclipse RCP application called ToolPlan, which is a project management application allowing to do all kind of project management tasks. We have no ties to that. I just chose that because one could download a free version, and it's a mid-sized complex RCP application. And the test case I want to automate is to assign and rename a user role. So basically what we will do is we open this application, create a new project. In the project management tree, navigate to through the teams in the management team to a person, open that person's profile, assign that person the role project manager. Then we will go to the roles in the project management and rename the project manager role to project lead. And after that, we want to automatically verify that the role in the person's profile has been renamed properly as well to check that the renaming works. And then we delete the project and exit. So that's what we want to test. And with that, let's start with the live demo, which will be first to record the test, then look at the test script and start refactoring it. So for that, I will start on Windows and will later run the same test on my Mac to show the cross-platform support. So I'll start with a new test suite. To plan. Then I want to do a Java test, which supports all kinds of different Java UI technologies, including RCP. Then I can choose between different script languages here to automate my test scripts. I will use Python for myself, since it's a language I prefer myself for test creation. And finally, I will choose the application which I want to automate, which is the launcher of the two-plan RCP application. With that, I finished creating this new test suite and creating a test case, rename role, and start by recording. This now launches the application or test which I just specified before. And that error sometimes pops up, but doesn't matter. And now everything I do on this two-plan application will be recorded. So I will start by creating a new sample project. And in this little control bar, you see the kind of interactions which are recognized by Squish. Then I go into the teams, open that up, into the management team, and click this one person. In here, I click on roles, add a role of project manager, and say OK. And now, while recording, I will directly insert a verification point. I can insert different kinds of verifications here. I'm going to do an object property verification to check the text property of this table or a list item. When doing that, I'm able to drill down into the whole object hierarchy of my RCP application, since we bind directly to the Java virtual machine through introspection, so you can access anything, any kind of objects which are available in there. But now finding the specific object, this tree item to inspect in this object tree would be rather tedious, so I can use our visual picker, which allows me to visually pick the object I want to inspect and insert a verification for, which is this tree item. And I tick the text checkmark to insert a verification point for the text property of this item. After inserting that, I now switch to the roles, as I had defined before, open that up, and open the project manager and rename that to lead. Then I switch back to that person and insert a second verification, checking again the text here to ensure that it changed to lead. So I repeat that exercise. And with, when having done that, I will now delete the project and exit from the application. And after exiting, Squish now generates the test script from the recording, which even with this rather simple test case already is a rather long list of statements, which is the first indication that we should do some refactoring in a moment. So what we see here is that all the interactions have been recorded, starting application, interacting with the menu, interacting with the items in the tree, doing the verifications in there. One important thing is also how objects are identified. So just a very quick excursion to that. We abstract that into a so-called object map, where each object name maps a so-called real name, which is a list of values and properties to uniquely identify the object in the user interface. And what properties are used in there is depending on object type and other conditions, and can be freely defined, but is predefined for all standard controls. So with that, the object naming is abstracted away into one central place to ensure that if changes happen, we have just one central place where you need to do modifications. So now we can just quickly run the test to see if it works before we start refactoring it. So that's just this application sometimes gives these errors, but they don't matter too much. Usually, they don't matter too much. And after that, we got the two results from the comparisons that everything passed. But that's really just the initial step to generate some script code. The next step would be to think, again, more in the high-level steps of the test which we wanted to automate and start creating functions for each high-level step in the application. So one would be to make a function create project with a name, and then we basically just take the code to create a project, make it more generic to allow creating all kinds of projects. No. And call that function. Another thing we could, which we repeatedly do, is navigating in this project tree. So we could create a more generic function for that navigate project tree, which allows up to 3 nodes in the hierarchy to navigate. And then we can just take some of that code. Just need that. So we just click on node 1. And here you may wonder what those numbers are. That's relative coordinates within the tree's items, which usually don't matter. So we can just remove all of that, since we just want to click into the middle of the item, so we don't need the specific coordinates within the item. So we want to click that. Now if the node 3 is not empty, so if a third node is specified, we want to or we want to click on the second, and then we want to open the second one as well, so we can expand. And else, oops, there is a column missing. And else we want to expand second. Then we want to click the third. And then we would just start using this code in there. So that's teams and so on and so forth. So I will not bore you with doing the whole refactoring live here, but just to give you the idea that we should not just keep the recording as it is there, but just use it as an inspiration of how we can actually code our test. And I have already prepared, of course, all of that in one ready-made project test suite, where I refactored all of that. So basically what it ended up with is that I have all those functions in here refactored from the recording, and my real test script is just this code down here anymore, which just calls those functions with the specific arguments. The next step would be that, of course, a lot of those functions which I have in there could be well reused across several tests. So I have created a shared library of those tests where I moved those functions to, and then the real final test script looks like that, where I'm just loading those shared steps test script file and just calling those functions with the different parameters. So I can just run this test once real quick to ensure that it really works. And that works as expected, and of course gives me 2 passes. So when we now switch back to the slides, so we basically did those steps. We recorded a test, we looked at the test script, at the object names, refactored it, and redid the test by using our refactored functions instead of just a basic recording. So the next step, since we want to do cross-platform testing, would be to use the exactly same test and run it against the same application on a different platform. Now one possibility would be to just copy over everything to, for example, the Mac then, and run it from there. But due to our network transparent testing architecture, it's actually possible to have the test script executed on one machine and connect through an agent, the Squish server, to another machine on which the application or test will be launched and automated. So that's the setup which I will show here, where I will still execute the test on the Windows virtual machine, but the actual application will be run on the Mac. So to do that, I have on my Mac, I have started, or can restart it here. I start the Squish server, which is this agent which is listening to connections from a test runner, and then the server will launch the application under test, and all commands like clicking and verifications will be sent over the network. And on my Windows machine, what I will do is I will go into my preferences, and instead of using a local server or agent, I will connect to this IP address, which is the Mac's IP address and the port on which we just started the Squish server, and connect to that. So now, just to see that a bit better, so I'm now running the test from here, and we see it connects to the server, see some output there, and now the Mac version of Tupline is started. You see it's now interacting with the Mac menus, and it's still exactly the same test we ran it before on Windows, but now running on the Mac, showing that the test works across platforms since we interact with the SWT RCP controls and don't care about the platform itself, and have abstracted the platform differences away from the user to ensure that those tests can work cross-platform. So with that, we ensured the cross-platform support of the test, and that allows us to go one slide further, which is set up some kind of automation. So the first step for that would be, of course, to check everything into our revision control. Everything are just plain text files, so it can be treated like any source code. And then to integrate that into, for example, Jenkins, for which plugins exist, or any other kind of ALM or continuous integration solution. And there we can also utilize this remote testing facilities of Squish again. For simplicity, I have not done a complete Jenkins setup here now, but I'm just using a set of scripts to do this automated execution. So basically, I have here a small Python script which allows to run tests through our Squish runner tool by passing some parameters to it, where to run it and so on, and one configuration file where I specify my test suite, and then the host on which I want to run everything, where to put the results which we're generating as HTML, and here I commented it out. Of course, one step we would need to do is to ensure that the application is deployed everywhere. The Jenkins job would automatically do that, but just to get the idea of the steps which are necessary for the full automation to run. So with that script, I'm starting once the Squish server here on this Windows machine to run the test once on Windows, and I already have it running on the Mac. And with that, I will just execute this Python script to run the tests now. So now we're running everything from the command line and running the test once on Windows, one on Mac. Of course, it could also be parallelized to reduce the timing, but to avoid too many windows popping up. Here, I just did it one after the other, or let it do one after the other. And now it's the Mac test which is being executed. And once that is done, we can inspect the HTML result which is being generated, which we have here. It looks very simplistic, but it's just very simple. The results from this execution as a very plain HTML output. But as said, usually would integrate that into Jenkins, where you have a tight integration and a much nicer view of all of that. But still, you would now have an HTML report which could be accessed by different people after the run to verify if everything is fine or not. OK, let's see. With that, I'm done with the presentation or the demonstration. So just as a short recap, what a Squish GUI tester can do. So I mainly focused on RCP testing now. But as I said initially, our vision is to create a cross-platform, cross-UI technology test automation tool, which runs on pretty much any platform, so not only Windows, Linux, Mac, but also several real-time operating systems, mobile, and still Solaris, AIX, and other Unix systems. Support a range of different UI technologies, Eclipse RCP I just have shown, but also Swing, also JavaFx, and then outside the Java world, the native Windows, Mac ones, the mobile toolkits like iOS and Android, Cocoa on the Mac, I mentioned already, Qt on pretty much any platform. And our strength is really that for each of the technologies we support, we implemented the same kind of integration as you have seen for RCP here, which is very tightly integrating into the UI technology you're testing, giving you full access from the test scripts to all the APIs of your UI toolkit and even the application to allow implementing also more complex test scenarios. Everything is very scripting-centric, as you've seen. The development environment is Eclipse-based, but everything can be run through command line tools. And we also offer integrations into all kind of test management, ALM, and continuous integration tools. If you have any more questions, you can ask them now. We also have a booth over there, so feel free to come by. And you can also, of course, get a trial if you want.
Yes, quick question.
Of course.
When you're running, for example, batch testing using Jenkins Hudson, do you need a machine with the display, or is it possible to have like virtual?
We don't need a machine with display, but your application needs a display. But of course, if you are, for example, on Linux, everybody uses XVNZ there, and we use it ourselves for all our internal testing too. So it's very common to use virtual frame buffers, virtual devices. You just need some display for the application to operate. Otherwise, a UI will not show and no rendering will happen. Yeah. Yes.
Do you support Draw 2D as well for GF editors?
Sorry?
Do you support Draw 2D?
So we have a GF support. So we detect GF objects as distinct UI objects, also based on the properties and things like that. You can do draggings and resizing and so on. So